Hello friends, welcome to your channel Make Physics Easier by Mayur Agrawal. Today I have selected a topic related to physics subject, how to solve graphical questions in one-dimensional motion. Because according to the syllabus of class 9th, such type of questions are very important for your exam pattern. Now, in my previous videos, I have given you how to understand the graphs related to one-dimensional motion. But I have never given you any video in which I have discussed numericals. So for that purpose, I have selected the concise physics book. But these questions are very important for all the students because book doesn't matter. If you have understood the concept, then the questions from any of the book you can solve. So let's start today's video without any delay. My friends, my students, I would like to request you, those students who are watching my channel, then please subscribe and share among your friends so that I can achieve 1000 subscriber very soon. And as I get the 1000 subscriber milestone, then I will definitely take online classes. Okay, thank you for that. Now, the first numerical is saying that regarding concise physics book, in this there is a graph related to distance and time. There is a graph made that is of displacement. On the y-axis, displacement is there in meters, and on the x-axis, time. Graph is like this. The values are also given. So in front of 2, that is 1 second, and after that in front of 4, that there is 2 seconds, and there is 4 meter. After that there is 6 meter, so 3 seconds, there is 3 second and 6, and at last 8, and here 4. So the graph is a displacement time graph, it is given. So from this graph it is very clear that the displacement of the object at 1 second is 2 meter, at 2 second 4 meter, at 3 second 6 meter, at 4 second 8 meter. So from the graph, very clear the relationship between displacement and time. The question is saying that figure A, this is the A figure, shows the displacement time graph for the motion of a body. This is the graph for the motion of a body. Now we have to use it to calculate the velocity of the body at t is equal to 1 second, t is equal to 2 second, and t is equal to 3 second. Then draw the velocity time graph. Then we have to draw a different graph between velocity and time. This is velocity and this is time. So first of all, we have to calculate the velocity. So first of all, we have to understand that how can we find the velocity with the help of displacement time graph. So look at carefully. Velocity is equal to slope of the graph. That is basic concept of finding the velocity. This information I have given the previous video, so you can go through my channel and find that video in which I have explained in very detail. So velocity, when we have to find the velocity with the help of displacement time, then we have to find the slope, and the formula for slope will be y2 minus y1 upon x2 minus x1. So suppose we are talking about t is equal to 1 second. So this coordinate will become the x1 y1, and the coordinate over here, suppose we named it A. This is O, A, B, C and D. Suppose we named it so that it will become very easy. So basically we are finding the velocity in part OA. So the coordinate of O, that is x1 y1, and that is 0 0 because this is the origin. And the coordinate of A, we can consider it as x2 y2. The coordinate of x2 y2, 1 comma 2, because the apsica is 1 and the ordinate is 2. So now apply the value. So velocity is equal to y2 minus y1. So 2 minus 0 upon x2 minus x1. So x2 is 1 minus 0. So the answer is 2 by 1. Finally, the velocity will be 2 meter per second in the part OA. So when we make time 1, 2, 3, so the velocity is coming 2. Suppose velocity is written here 2, here 4 and here 6. So at 1 second the velocity is 2. So the first point on the graph will make on at this point. This is the first point on the velocity time graph A. Now we are going to find the velocity of we have to find the velocity at 2 seconds. It means we have to find up to the part AB. Now again the formula will be same, slope of AB graph. Now for the slope of AB, again we have to apply the same formula, y2 minus y1 upon x2 minus x1, but now the values will be taken of A and B. These two values will be taken. So for A, the coordinate of A will be 1, 2 and the coordinate of B will be 2, 4. Now we are going to apply the values. So y2 minus y1, 4 minus 2 upon 2 minus 1. So again 2 upon 1. Similarly 2 meter per second again. So again at 2 second the velocity is coming 2. Similarly when we find up to point C again with 2. So the graph finally become like this. A straight line, a parallel line to the time axis. This is the time axis because at each point the velocity is same. The velocity is 2 meter per second in each part. So in the velocity time graph, the graph will become parallel to the time axis and it passes through the 2 meter per second and it is parallel to the time axis. So this is the concept of displacement time graph. How can we achieve the velocity in each of the part, and after attaining the velocity we can make it on the other graph. So this is the question number 1. I hope so it is very clear. If you want to make you understand more clear that how can we find velocity deeply in detail, so you can go through my previous video. This is question number 1. Now let's come to the next question. The next question is given, a table is given in the next question. In the given table we have some values, time and displacement. Time is 0, then the displacement is 0. Time is 1, then the displacement is 5. Time is 2, the displacement is 10. Time is 3, displacement is 15. Time is 4, displacement is 20. This is the table. Draw the displacement time graph and find the average velocity. So first of all we have to make a graph. So we have made two axes. This is y axis and this is x axis. We know very well. On the x axis we represent time in seconds and on y axis we show the displacement in meters. Okay. So this is 0, 0, this is 1 second, 2, 3, 4, 5. All the displacement values are the multiples of 5. So it will be better option that we are making the multiples of 5 on the y-axis. So the first point is 0, 0. So the first point lies over here. Second point 1, 5. So one perpendicular line from here, one here. This is the second point A. Second point is 2, 10. So this is 10. And this is 2. This is the second point. After that 15, then 3. So this is the third point. After that 20 and 4. So this is the fourth point. So we have to make them all the points up to with a straight line. And always remember that if the gaps are clear, if the gaps are uniform, then there is always a straight line formed. So this is the graph for displacement time according to the given. And we have to find the velocity because the graph is a straight line. So it means the velocity is uniform. So average velocity is equal to slope of the graph. Suppose this is A point, B point, C point and D point. Slope of OD. O is the initial point and D is the final point. The coordinate of O is 0, 0 and the coordinate of D 4, 20. Now just fill the values y2 minus y1 upon x2 minus x1. These are the values of x1, y1. These are the values of x2, y2. So 20 minus 0 divided by 4 minus 0. So 20 upon 4, the final answer will be 5 meter per second. So the average velocity in the given figure is 5 meter per second. Now this is the A part. Now in B part we have to find what will be the displacement of the car at 2.5 seconds. So 2 and 3. 2.5 second will come just in between. So we can apply the formula also. Displacement is equal to velocity into time. We have two methods. Either we can solve with the help of graph also. If you have made the graph with proper scale, then you can do one thing. You can draw a perpendicular line to the mark of 2.5. Then where it intersects the graph, you have to draw a line perpendicular to that point. So the value between, just mid between 10 and 15, and the mid value of 10 and 15 is 12.5 meter. So you can find the value with the help of this also, and you can find the value of with the help of formula. Velocity is coming 5, time is giving 2.5. So the answer will be 12.5 meter. So both methods you have. You can find with the help of graph also. The time is given 2.5. So you have to make a perpendicular line on the graph with the mark of 2.5. Wherever it intersects the graph, from that point you have to make a perpendicular line on the y-axis. Where it cuts, where it intersects, that is the value. Similarly, at 4.5 seconds, so again formula, displacement is equal to, now velocity is 5 and time is 4.5. So the answer will come in 22.5 meter. So this is the way. So how can we solve the question number 2? So it is not compulsory that always we find all the values with the help of graph. Sometimes if it is possible, then we can apply the formula also. But always remember that when you are drawing the graph, then your scale must be proper. Taking the scale, taking all the distances must be proper, then only you can make the graph. And because graphical representation is very important for you and you have already some knowledge about it, you got that some knowledge in previous class. So right now you must not be any problem to make the graph. Now question number 3. Question number 3 is saying a body is moving in a straight line and its displacement at various instants of time is given the following. So again a table is given. So first of all we are making the table, time and displacement. Time 0, displacement 2. Time 1, displacement 6. Time 2, displacement 12. Time 3, displacement 12. Time 5, displacement 18. Time 6, displacement 22. And at last time 7, displacement 24. This is the values. Plot the distance time graph and calculate. So first of all we have to make the graph. So very carefully, this is y-axis, this is x-axis. Now displacement over here and time over here. This is 0. Time is given 1 in the terms of 1 only. So 1, 2, 3, 4, 5, 6 and 7. And the values are given in the multiples of 2 also. So but we have, if we want to make a graph very small, so we have to take the multiples of 4. 4, 8, 12, 16, 20 and 24. We have taken 4 gaps, interval of 4. The first point is 0 and 2. So 2 will be here and 0 will be here. So the first point of the graph lies here. This is the point O. Second is 1, 6. So 1 is here and 6 is just in between of 4 and 8. So one perpendicular line from this side, one perpendicular line from this side. So this is the second point of the graph, point A. 2, 12. So 12 is here. So one perpendicular line from the 12 and one perpendicular line from 2 mark. This is the third point of the graph, C. 3, 12. Again, 12 line is making more forward. And this line is from 3. This is point D. Now 5, 18. 18 lies just in between 16 and 20. So here 18. And 4 is not given. 4, 12 also. One more gap is given. 4, 12. So from the 4, 12. So E point lies here. From the 5, 18. So F point lies here. After that 6, 22. So 22 lies just between 20 and 24. So this is point F after FG, and point 24 up to 7. So the final point, this is H. Now we have to make. So first of all, we have joined OA, then OAC, then CDE, then EF, then G, and then H. So this is the graph. From this is starting, and sometimes it is parallel to the time axis. After that, again a straight line, because 18, 22 and 22 and 24. So this graph is not a uniform graph. We can say that because we can see that the values of the displacement are different. One value I have skipped out here, 4 and 12 also. So this is the graph related to question number 3. Now we have to find total distance traveled in graph 1 to 5 seconds. 1 to 5 seconds. So we can clearly say that 1 to 5 seconds, the total distance traveled, 1 to 5 seconds. So initial point is 1 second. At 1 second, the displacement is, at 1 second the displacement is 6 meter, and at 5 seconds the displacement is 18 meter. At 1 second the displacement is 6, at 5 second displacement is 18. So the answer is 18 minus 6, 12 meters during this time interval 1 to 5. And we have to find the average velocity in the time interval 1 to 5. Between 1 to 5 we have to find the average velocity. So average velocity formula is total displacement. Average velocity is equal to total displacement upon total time. So total displacement is coming 12 and total time is 4. So 4 3s are 3 meter per second. So these are the two terms which we have to find. Average velocity with the help of formula total distance upon total time, and total distance traveled that we have formed with the directly, because initial point is at 1 second. So at 1 second the object was at 6 meter, and at 5 second the object was at 18 meter. So the difference between these two positions give the distance traveled by the object between the 1 to 5 seconds. So this is the question number 3. So it is not compulsory that graph will always come a straight line. It is always of uniform velocity. It is not confirmed, it is not compulsory. Sometimes the graph may be a different way, may be made in a different way. So this is the question number 3. Now we are coming to the next question, question number 4. In the question number 4, the graph is given to us. Displacement time it is given. Here displacement, and on the y-axis time. The graph is made in this way. This is a line, after that sometimes parallel, and after that this is an inclined line. So the graph from this point, this is 3, and at this point this is 5, and this point 7, and this point 9, and this point, because these are the points where the graph is changing, 7. So this is in meter, and time is in seconds. Now we have to calculate the velocity 0 to 5 second. This is 0 to 5. Velocity 0 to 5 second. So suppose we named it A. So we can say that slope of graph OA. Slope of OA. So y2 minus y1 upon x2 minus x1. Now y2 means this value is 3. So 3 minus 0, and x2 is 5 minus 0. So the answer is 3 by 5. So we can say that 0.6 meter per second. This is the velocity 0 to 5. Now the velocity, we have to find the velocity 5 to 7. We can see that 5 to 7, the graph is parallel. So again we apply the same formula, y2 minus y1 upon x2 minus x1. So this is AB suppose. So here y2 is 3, y1 is also 3. So 3 minus 3 upon 7 minus 5. So 0 upon 2. Now the velocity becomes 0 between 5 to second. And after that velocity is 7 to 9. 7 to 9 is BC point. So again the formula will be same, y2 minus y1 upon x2 minus x1. Now y2 is 7, y1 is 3, so 7 minus 3, x2 is 9 and x1 is 7. So 7 minus 3 4, 9 minus 7 2. So the answer will be 2 meter per second. So in this part the velocity will be 2 meter per second. In last BC part, OA part velocity 0.6, AB part velocity 0 and BC part velocity is 2 meter per second. Now we have to calculate the average velocity during the time interval 5 to 9. Okay, now directly velocity 5 to 9. So average velocity because they are asking. So total displacement upon total time. This formula we apply between 5 to 9. 5 is here and 9 is here. At 5 second the object is at 3 and at 9 second the object is 7. So total displacement will become 7 minus 3 and total time will become 9 minus 5. So 7 minus 3 4, 9 minus 5 4. So the answer will be 1 meter per second. So when we have to find the average velocity, then we don't need to apply the formula. Then we have to find out the total displacement from the graph and total time from the graph. Then we apply both the values, then we got the answer. So this is the question number 4. So these are the 4 questions from my sides from the concise physics book. You can revise these 4 questions. If there is any doubt, then you can ask, or I hope so there will be not any doubt, because in the previous video I have explained you how to use a graph, how to understand a graph. Now in this video I have given you the solutions of some questions. The solutions of the next questions I will give you in a separate video. So just wait for that and watch the video, subscribe my channel, like. Thank you.